Alright, in this video I'm going to derive the vertex formula. We'll start with y equals ax squared plus bx plus c. And the first thing I'm going to do is just move c out of the way, because what we need to do is complete the square. So I have y minus c equals ax squared plus bx. Now treat a, b, and c like they're numbers. We can't complete the square if you have the a in front of x squared. So I'm going to divide it out of the right hand side, but rather than put it on the left hand side, I'll go ahead and just factor it out. So it looks like y minus c equals a times the quantity x squared plus b over a, x. Notice I put the a with the b. Again, I'm going to treat that as a number, so b over a is the coefficient of x. And I left space after b over ax because now I'm going to complete the square. So you take the middle coefficient, you take half of it, so half of b over a is b over 2a, and then I'm going to square that to get b squared over 4a squared. So that's what I need to add to the right hand side. Now I need to add the same equivalent value to the left hand side, but it's really not b squared over 4a squared because there's a factored out a. So if you multiply the a times the b squared over 4ac, the a times the b squared over 4a squared, you'll see that that value that was added to the right hand side is really b squared over 4a. So that's what I have to add also to the left hand side to keep the equation balanced. So then I have y plus b squared over 4a minus c equals a times the quantity. Now I factored it, okay, because that was the whole point of adding the part in red. So it's a perfect square. It's x plus b over 2a squared. So if you were to FOIL out x plus b over 2a times x plus b over 2a, you would get the trinomial in the step above it. And so now the last step is to get y by itself. So I have a times the quantity x plus b over 2a squared, and then I moved the b squared over 4a to the right hand side, and I also moved the minus c to the right hand side. So now I'm going to write it so you can see the vertex sitting in it. So instead of adding b over 2a, it's the same as x minus a negative b over 2a. And then I just put a plus in front of the last two terms so that you can see that the last two terms are the y part of the vertex. But that's pretty cumbersome. So what we're going to do instead is, you can see the x part of the vertex is negative b over 2a, and instead of trying to memorize the other portion for the y part, then whatever negative b over 2a is, like say it's 5, then you just plug 5 back into the function to get the matching y value. So that's why it says f at negative b over 2a.